All right, let's dive right in. What we've got here is a classic David versus Goliath story, but it's for the age of AI. And this battle isn't just about raw power, it's about pure, mind-bending speed. So a demo started making the rounds online recently that was, frankly, a little startling. It showed a large language model answering a prompt, but not with that slow, typewriter effect we're all used to. Nope. The entire block of text just appeared, instantly, all at once. This was definitely not the AI experience we've all come to expect. And here's the kicker. The chip making this happen wasn't from NVIDIA, the undisputed king of AI hardware. It was from a startup called Groq. And that, right there, raises the big question for today. How did they do it? What in the world is the secret to that kind of speed?
To really get what Groq's solution is, we first have to wrap our heads around the problem. Because while AI can feel like absolute magic, its performance is often shackled by a very real and very frustrating bottleneck.
And this is the core of the issue, what engineers call the memory wall. See, in most computer systems, you have these incredibly powerful AI processors that spend a shocking amount of their time doing, well, nothing. They're just sitting there, completely idle, waiting for data to travel from the external memory chips. It's like having a Michelin star chef who has to wait for every single ingredient to be delivered, one by one. That delay, that's the biggest drag on AI speed. So here's a super important point. AI hardware really has two totally different jobs. There's training, which is like building the AI's brain. That takes massive parallel computations. Think of it like using a whole fleet of giant cargo trucks to move a mountain of data. But then there's using the AI, what's called inference. And that's a whole different ballgame. It's not about bulk, it's about a lightning-fast response. You don't need a cargo truck for that. You need a Formula One car, a machine built for one thing and one thing only, pure speed. Which, of course, brings us to our two main contenders in the ring today. In one corner, you've got the reigning champion, NVIDIA's GPU, the ultimate all-purpose workhorse of the AI world. And in the other corner, you have the challenger, Groq's LPU, which is a completely different kind of beast, designed from the ground up to be that Formula One car. So let's break this down, a little tale of the tape. As you can see, NVIDIA's GPU is that versatile champ, built for both training and inference. It works by using these big pools of memory that are off-chip, which is super powerful, but it's what creates that travel time, that memory wall we just talked about. Groq's LPU, it's the complete opposite. It is built only for inference, and it uses a special kind of memory called SRAM that's right there on the chip itself. And this choice is the key to its predictable, or what they call deterministic design. One is the all-purpose truck, the other is that highly specialized Formula One car. So what is Groq's secret sauce? What's the big idea? Well, it's not about just having more raw horsepower. It's about a completely different philosophy of how you do computing. And it all comes down to this one word, deterministic. Okay, so I've thrown that word out there a couple of times now, deterministic. What does it actually mean for a chip to be deterministic? Because this, right here, is the key that unlocks all of Groq's crazy performance. Think of it this way. A deterministic architecture means that the software, the compiler, figures out every single calculation and every single data movement before the program even starts to run. It's all pre-planned, down to the nanosecond. There are no surprises, no data traffic jams, and almost no waiting around, because the hardware never has to guess what to do next.
And this just illustrates the difference perfectly. The normal GPU approach is kind of like a chaotic city intersection at rush hour. You've got all these data packets competing for the same space, creating unpredictable bottlenecks and delays. The LPU approach, on the other hand, is like a perfectly synchronized train schedule. Every piece of data is on a specific track, it's scheduled to arrive at a specific platform at a specific time. No conflicts, no waiting, just perfect, predictable flow. Now, that perfectly timed train schedule is only possible because Groq made a really radical choice. They completely ditched the standard big memory chips that live off to the side, and instead they put smaller but incredibly fast SRAM memory directly on the processor itself. This completely eliminates that travel time. It tears down the memory wall we were talking about earlier. But, and this is a huge but, that radical design creates a massive trade-off. It's an engineering puzzle that actually forces them into a completely different kind of business model. So here's the paradox, right? That on-chip SRAM is unbelievably fast, but it's also tiny. A single Groq chip only has about 230 megabytes of memory. So how on earth do you fit a massive AI model that takes up gigabytes and gigabytes of space?
Well, the answer is you don't. You don't use just one chip. You use hundreds. Groq's big idea was to connect all these individual chips together in a server rack and program the entire rack to act as one giant, cohesive megachip. All the AI model's data is spread out across this huge network of chips, letting them all work together as one single perfectly deterministic system. And this unique design leads to the punchline of their entire business strategy, summed up perfectly in this direct quote from the company: "We don't sell chips." Right, because their chip is actually the whole rack. You can't just go out and buy one. It wouldn't even make sense. Instead, Groq sells access to its hardware through the cloud. They aren't selling you a piece of silicone, they're selling speed as a service. So, the big question: does all this radical engineering and this speed as a service model actually pay off? Well, the results are pretty staggering, and they start with this number right here: 10x. Now, that 10x isn't speed, it's energy efficiency. Because the LPU isn't wasting all that time and power just shuffling data back and forth, it can generate about 10 times more text for the same amount of electricity. In tech terms, that's better joules per token. And trust me, for any company trying to run AI at a massive scale, that kind of efficiency means huge, huge savings on their power bill. And then there's the raw speed. I mean, just look at this. When running the popular Llama 2 model, other cloud services using traditional chips top out somewhere under 50 tokens per second. Groq's LPU, yeah, that's delivering around 241 tokens per second. It's not just a little bit faster, it's in a completely different league. So, what does all of this mean for the future? Well, it signals a major shift that's happening in the AI hardware world. The race is changing. You see, for years, the whole industry has been obsessed with training, just building bigger and bigger models. But now, as AI gets woven into all of our daily apps, the focus is shifting to inference, the user experience, how fast and responsive the AI feels to you and me. That's becoming the metric that matters most. So let's just tie this all together. We started with the memory wall, that fundamental speed limit holding AI back. Then we saw how Groq just shattered that wall with this radical, deterministic design built on super fast on-chip memory. That choice then forced them into this unique, cloud-only business model where they're selling pure speed. And what this all really signals is a brand new era, where specialized hardware, built for one specific purpose, is coming to challenge the one-size-fits-all champions. In the end, what Groq is really doing is making a fascinating bet. They're arguing that, in this new age of AI, brute force isn't as important as perfect, predictable execution. And it really leaves us with a pretty cool thought to chew on. Maybe the smartest chip isn't the strongest one, but the one that is the most disciplined.